who are joining us have questions, please put them in the Q&A and I will sort of moderate that. We had one question earlier during Terry's presentation on recyclability. I will say, yes, it's recyclable, but I'll let Terry answer that because US Vanadium's been a leader in doing some work in that area. We'll start off with our first question. This is for GJ. Is the TIFAST presentation confidential? It shouldn't be.
No, it shouldn't. It's not. That's our standard sort of deck. It's got the wording at the bottom. No, this is a public forum.
We'll remove that when we send out the deck afterwards then.
Great.
Question for Brian. How much cost reduction impact will the new cathode material have on the cell cost? Energy density and cycle performance and cycle live data, is that available at all? So first one is, how much cost reduction impact will the new cathode material have on the cell cost?
So the overall cell cost reduction is about 20%. So you can think about it as and again, that's estimated from some modeling that we do within battery programs that are available, like that are published, like Celeste and BATPAC being from the Department of Energy. But yeah, so it's about a 20% cost reduction and an equivalent performance to something like nickel, manganese, cobalt, which is the high energy density cathode used today at the cell level. Question 2. We do have a lot of data available, not publicly available, but we do have a lot of data available. And if you'd like to see more about that, I'd encourage you to reach out and contact us, and we can go ahead and go through that information and that data more regularly. But yeah, the vanadium material is highly energy dense and very cyclable.
Great, thanks, Brian. I think this one's for GJ. For the fast charge wearable applications, how does the business model for replaceable zinc air batteries compare to the fast charge vanadium business model?
So replaceable batteries, in essence, you replace to basically get back to full power, full strength, full runtime. I don't know so much about the zinc air space. My understanding is it's essentially potentially a 20-hour marathon, or maybe even 30-hour sort of long run downtime. Discharge time. Whereas in our case, and one would effectively have to just replace and have a package of cells available. In our case, the idea here is for fast charging is one could essentially hermetically seal the battery in the device, number one. Number two, never have to replace the battery over the service life of the device. And number three, basically, in applications that can handle a few minutes of downtime, we could get you back to full charge faster and get you back to, in this of a wearable application, back to life faster.
Great, thank you, GJ. I think we have a question from Mikhail himself. So Mikhail, go ahead and speak. Well, here's his question. He'd like to know what would happen if a dimming cathode were combined with a TIFAST anode in a lithium battery. I'll let either of you answer that, or both of you.
I think it'd be exciting, is what I think it would be. I don't know. I'm sure maybe GJ and I will have some follow-up conversations after this call and see if something is possible. But a vanadium anode cathode battery certainly seems interesting to me.
Yeah, so I could add to that. The possibilities of that, I think, are super exciting. I've agreed. There's a high recyclability platform now, given that it's a material that's highly valuable from a secondary use case. And the key question would be, from my standpoint, is what applications what properties would it have, and what applications would be most advantageous at? So that's a great question. We've actually been thinking about that for a while. But just haven't, maybe found the right cathode yet. So we should definitely connect with Brian.
All right. Great. Well, thank you all. I think that's all the questions we have for this session. Thank you both. Great presentations, very exciting stuff. I think we're now going to go back to Terry. Terry, are you there and available?